Hey you guys, well welcome to zero and negative exponents. One of my favorite lessons, you will see in class how crazy I can get. But here's the deal, with negative exponents, I want you to just think of fractions. But to make it a little more fun and help you understand it, I want you to imagine that you're at a pool party, okay? And here's the deal, when I talk about a fraction, think of the fraction bar, and in the denominator, that would be people in the pool. And on top of the fraction in the numerator, that would be people out of the pool, okay? So I'm going to be using this story to help you understand negative exponents in just a second. All right, but let's start off with the first thing. It says let a be a non-zero number, and then let n be an integer. So here's the deal. A to the 0 power is always 1, all right? So a to the 0 power is 1. In fact, anything to the 0 power is 1. So 4 to the 0 power is 1. A to the 0 power, 1. A million to the 0 power is 1. So anything that power of 0 is touching becomes 1. Okay, now here's the thing about the pool party, okay? If you have a to the negative power, I want you to think of a pool party where a is the parent, okay? So one of these guys, like here's a mom and here's a dad. So a is the parent, and the negative power is the little bitty baby. See the baby they're holding? Okay, here's the deal. A to the negative n power. The parent A is holding the little baby, but since it's negative, the baby is sad and crying because they're at a pool party and they want to get in the pool. So we will write A to the negative n power and then draw the fraction bar, and there's always a 1 underneath, that invisible 1, okay? Now here's the deal. A mom or a dad cannot just throw their baby in the pool. That wouldn't be cool, okay? They have to get in the pool with the baby. So I want you to circle the parent, the base, and the negative exponent, and put an arrow going down to the pool. Because what happens is, here's the fraction bar, okay? And now there's a 1 on top, because there's always a 1 on the top and there's always an invisible 1 on the bottom. But there's a 1 on the top, but look at the parent got in the pool with the baby, and look what happened to the baby. See how the baby was negative when it was outside of the pool? But now that it's in the pool, it's happy because it wanted to play in the pool, so it becomes positive. Okay, so here's the deal. Anytime you see a negative exponent, it's your job to make it happy, okay? So here's another situation. 6 to the negative 4th power. So 6 is the parent, and the negative 4 is the little crying baby. So circle them together and let them get into the pool. So now, draw your fraction bar. There's a 1 on top. The parent is the same, but look at what happened to the baby. It became happy and positive. So it's 1 over 6 to the 4th power. All right, now the opposite could happen too. So let's say here's a parent and the baby is perfectly happy not in the water. But the parent decides to get in the water with the baby. Well, look at what happens. Here's the fraction bar. The parent stays the same, but look at what happened to the baby. The baby started crying. It became negative, okay? So if the baby's happy outside of the pool, leave it alone. If you drag it into the pool, the baby's going to cry and become negative. Here's another situation. Let's say 8 to the 3rd power. We draw a fraction bar, put a 1. If you grab the parent and the baby and put them in the pool, the baby's going to start crying. It doesn't want to go in the pool. That would be 1 over 8 to the negative 3rd power. Okay, so take a look over here, and remember, think of the pool party as I'm talking about this. Look at example 1, letter A, 4 to the 0 power. Well, anything that has the power of 0 instantly becomes 1, and you're done. Anything that little baby 0 touches becomes 1, okay? And that's the definition of a 0 exponent. Take a look at B, 2 to the negative 5th power. Well, as soon as I see a parent and a little crying baby, I draw the fraction bar and put a 1. And then with my red, I circle the parent and the baby, and I let them climb in the pool. Because remember, the baby wants to go in the pool. So now it's 1 over 2 to the positive 5 power. The baby became happy in the pool. And then to figure out the answer, we just write it out. So it's 1 over, and then I write out 2 times 2 times 2 times 2 times 2. And then I just multiply. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this becomes 1 over 32, and I box my answer. take a look at C. This is kind of fun, okay? So C in parentheses, how it's 1 over 3, and then the negative 2 is on the outside. Well, you have to give this little baby to the 1 and to the 3. And I guess you can think of it as twins, okay? So give the little baby to the 1 and to the 3. So we have 1 to the negative 2 power over 3 to the negative 2 power, okay? Now here's the thing. The parent with the baby outside of the pool, this baby wants to get in the pool. And here the parent with the baby in the pool, the baby, maybe it's too cold, it just wants to get out of the pool. So they have to climb out of the pool. So I drew with my red, I let the 1 with the negative 2 go down and get in the pool. And then the 3 with the negative 2, I use blue and I let them climb out of the pool. And now their babies are happy. So now it's 3 to the positive 2 power, this baby is happy, over 1 to the positive 2 power. This baby is happy. And so 3 times 3 on top makes 9. 1 times 1 on the bottom makes 1. 9 over 1 equals 9. Okay, so look at example 2 with me. Computers. The speed of a computer chip is measured in nanoseconds. 1 nanosecond is 1 over 1 billion seconds. Write 1 nanosecond as a power of 10. Okay, so 1 over 1 billion. Well, the fastest way to write 1 billion as a power of 10 is it's just 10 to the, and then I count the zeros. I see 9 zeros. So 10 to the 9th power is the same as 1 billion. And now they want me to grab this parent and the baby and take them out of the pool. Well, I bet you can imagine what happens. See how the baby is happy down in the water? If we say, oh no, it's time to go, time to get out of the pool, and we take them out, they're going to become very unhappy, very negative. So this becomes 10 to the negative 9th power. So if I wrote it as a power of 10, it would just be 10 to the negative 9th power. Okay, take a look at example 3. They gave us x to the 4th power times x to the negative 7th power, and then they want us to evaluate when x equals 6. Alright, so the first thing I did was I put a 6 in anywhere I saw an x, and I wrote it over here. So x to the 4th power became 6 to the 4th power, and x to the negative 7th power became 6 to the negative 7th power. And then I just drew my fraction bar and put a 1 in the pool. Now, this parent and this baby are perfectly happy out of the pool, so don't bug them, leave them alone. But this parent and this baby, the baby's crying, so they want to get in the pool to make the baby happy. So I have 6 to the 4th power on top over 6 to the 7th power on the bottom. Now the way that I'm going to evaluate it is just write it out. I know that 6 to the 4th power means 6 times 6 times 6 times 6. And I know that 6 to the 7th power means 6 times 6 times 6 times 6 times 6 times 6 times 6. Okay, so the first thing we do is write it out. And then we're going to strike out anything that matches. So 6 divided by 6 makes a 1. So these two cancel out. And these two cancel out, and these two cancel out, and these two cancel out. Now remember, I put my invisible 1 here. There's always a 1 outside of the pool, and there's always a 1 inside the pool. Okay, so that gives me 1 on top over 6 times 6 times 6. Well, 6 times 6 is 36, and 36 times 6 gives me 216. So this gives me 1 over 216. Okay, take a look at guided practice. Remember, it's best if you try it before you hear me explain it. You should try it first. Number 1 is 5 to the negative 5th power. As soon as you see that negative power, I want you to draw the fraction bar and put the 1 in the pool. And then grab the parent and the baby and let them get into the pool. So the baby's going to be happy. So this becomes 1 over 5 to the 5th power. See how the baby became happy? And then we just evaluate it. We write it out. So that's 1 over 5 times 5 times 5 times 5 times 5. And if you multiply that all out, which I did, you should do in your note-taking guide, I got 1 over 3,125. Okay, take a look at number 2. See how it's negative 3 in parentheses. That means this parent is grumpy, okay? Sometimes parents get grumpy too. You know that. So this is negative 3, that's the parent, and negative 3, that's the baby. And so I draw my fraction bar and put my 1. Now grab that parent and the baby and let them climb in the pool. And now here's here's what happens. Remember, there's always a 1 outside of the pool. Put your fraction bar. Now I want you to notice something. The parent, the base number, never changes. You know that sometimes your parents are just grumpy and that's the way they are. It happens, okay? But the baby always changes. When the baby's grumpy outside of the pool, it's going to be really, really happy inside of the pool. So this becomes 1 over negative 3 in parentheses to the third power. And then we just write it out. 1 over, and then notice how I repeated the parentheses. Negative 3 times negative 3 times negative 3. So that gives me 1 over, and negative 3 times negative 3 is 9, and 9 times negative 3 is negative 27. So it's 1 over negative 27. Now look at number 3, 8 to the 0 power. As soon as you see that power of 0, it instantly becomes 1. Okay, that's the power of 0. All right, then take a look at number 4. Evaluate when x equals 3. And they gave me x to the negative 4th power. So the first thing I did was put a 3 in for the x. So I have 3 to the negative 4th power. As soon as I see that little baby all sad, I draw my fraction bar and put a 1. Then I circle the parent and the baby, and I let them climb in the pool. So that becomes 1 over 3 to the 4th power. Remember, the baby becomes happy in the pool. So I get 1 over 3 times 3 times 3 times 3, and that's 1 over 81. Take a look at number 5. It's x to the 0 power. Well, even if I put in a 3 for x, 3 to the 0 power, anything that the 0 power touches instantly becomes 1. All right, take a look at number 6, 4 to the negative x power. So I put the 3 in for x, so that becomes 4 to the negative 3rd power. So the baby is unhappy, it's so sad. So I put the fraction bar and the 1, and then I carefully circle the parent and the baby and let them climb into the pool together. So this becomes 1 over 4 to the positive 3 power. And that means it's 1 over 4 times 4 times 4, and that means 1 over 64. Okay, let's take a look at example 4, simplifying. So I have negative 9x to the 0 power. Well, it's really important that, remember there's that invisible multiplication symbol between the negative 9 and the x. So separate them. Put negative 9 times x to the 0 power. Now let's just bring the negative 9 down, but the x to the 0 power, remember, anything that 0 power touches instantly becomes 1. So this means negative 9 times 1, which is just negative 9. Okay, here, look at B. Negative 3 times a to the negative 4th power. I highly recommend that you separate them. Put negative 3 times a to the negative 4th power. Now remember, you know that invisible 1 we've talked about? Well, there's an invisible 1 right here. So the negative 3 has a little bitty baby that's a positive 1. So this negative 3 parent and their little baby, they don't want to move. They're happy outside of the pool. Leave them alone. But the a to the negative 4th power, well, this guy has a baby that's crying, so they want to go into the pool. So that means I have negative 3 on top, and then there's always that invisible 1 on top. But the a to the 4th is down in the pool now because the baby is now happy. So that means this would be negative 3 on top over a to the positive 4th power down in the pool. Okay, take a look at C. It's 10 times t to the negative 3rd over t to the 2nd power. So the first thing I did was separate it. 10 times t to the negative 3rd over t to the 2nd power. Now the only person that has to move is the one with the crying baby. See how the t to the negative 3rd power is the only one that has a crying baby. The 10 doesn't have a crying baby, and this t in the pool does not have a crying baby. So these are the only guys that are going to move. So circle them in red and let them climb down into the pool. So now I have 10 outside of the pool over t to the 2nd, they were happy in the pool, and now t to the 3rd power, his baby's happy in the pool. Okay, so I have 10 over, and now I'm going to write it out. T to the 2nd power is t times t, and t to the 3rd power is t times t times t. So if you count, there are 1, 2, 3, 4, 5 t's. So this would be 10 over t to the 5th power, and you can box your answer. Okay, take a look at the guided practice, simplify. So I want you to try these before you hear me explain them. So if you need to pause, pause now. All right, so look at number 7. 5 times y to the negative 3rd power. the first thing I did was separate them. 5 times y to the negative third power. When I see that negative power, I draw my fraction bar and put my 1. Now the only person that has a crying baby is the y, so I'm going to circle the y to the negative third power, and I'm going to let them climb in the pool. So leave the 5 alone, they're happy, up out of the pool, over, and then I have y to the positive 3 power in the pool. Okay, take a look at 8. N to the negative 11th power times n to the negative 5th power. Well, both of these parents have crying babies, so they're both going to want to get in the pool. So draw your fraction bar, put the 1 there. Okay, so let's circle this guy first. So this parent with their baby is going to climb down in the pool, and this parent with their baby is going to climb into the pool. So now I have 1 on top. Remember, don't leave nothing on top. There's always a 1 on the top, and there's always a 1 on the bottom. So 1 over, and now I have this guy has a happy baby, n to the 11th power, and this parent has a happy baby, n to the 5th power. Now if you wrote it out, there would be 11 n's right here, n times n times n times n times n, and there'd be 5 more, n right there. So all together, it's n to the 16th power in the pool. Okay, take a look at number 9. I have 8 p to the 2nd power over p to the negative 4th power. So the first thing I do is separate them. 8 times p to the 2nd power, and then I draw the fraction bar, and then p to the negative 4th power is in the pool. Well, this parent has a little baby that's crying, and they have to get out of the pool. So circle the parent and the baby and carefully let them get out of the pool. So now I have 8 p to the 2nd power times p to the 4th power, all outside of the pool, over, and remember there's always that understood 1 in the pool. And so now I'm just going to put things together. So the 8 is outside of the pool, and if I wrote the p's out, this would be p times p, and right here it would be 4 more, p. Okay, so when you add those all together, that would be 6 of them. So it's 8 p to the 6th power over 1. But notice how I put the over 1 in red, because you really don't need it. Everybody's out of the pool, so it's just 8 p to the 6th power. Okay, take a look at number 10. 15x outside of the pool over 3x to the 10th power in the pool. Okay, so what I'm going to do with this is write it out, strike it out. So 15 I can break apart as 3 times 5, and then I just put my times x. And now I put my fraction bar, and down in the pool I have 3 times, and then I have 10 x's. I wrote them all out. Okay, once you write it out, then you strike out anything that matches. So there's a 3 on top, a 3 on the bottom, strike them out. There's an x on top, an x on the bottom, strike them out. And then just write whatever you have left. I have 5 on the top, and then if you count, there are 9 x's on the bottom. So it's 5 over x to the 9th power.